Let's now talk about this problem involving the difference of two proportions. So the null hypothesis in this case will be that proportion 1 will be the same as proportion 2. While the alternative hypothesis in the statement of the problem is that machine 2 produces a larger number, so that proportion 1 is less than proportion 2. So we will use the test statistic Z. So we have 960 divided by 1,000 is the proportion for 1, minus the proportion for machine 2 is 582 divided by 600. And so that's the difference of the two proportions. So that's the observed difference minus the expected difference divided by the standard error for the difference. The standard error for the difference has the formula square root of 1 over 1,000 plus 1 over 600 times the square root of pi times 1 minus pi. And our estimate for pi under the null hypothesis is that we have 1,600 total attempts, 1,000 plus 600, and we have 1,542 total successes. And that number is 960 plus 582. So that's our estimate for pi times 1 minus our estimate for pi. Okay, so let's type that into Excel and see what we get. So we have 960 over 1,000 minus 582 over 600 divided by the square root of 1 over 1,000 plus 1 over 600 times square root of 1,542 over 1,600 times 1 minus 1,542 over 1,600, which gives us a z-value of negative 1.036. The next step is to figure out the p-value, and the p-value will come off the bell curve. So there's negative 1.036, and in this case I need the area to the left. So if that's the z-value, the p-value will be equal to norm s dist of the number we just got, which is about 0.15. That number is bigger than alpha, and so our conclusion is we retain the null hypothesis. We do not have enough reason to think machine 1 or machine 2 produces a larger proportion of rods meeting the specification. And so that is our answer. Of course, we could have used the critical value as opposed to the p-value to make that determination.